Today we're starting section 7.3. We are going to add and subtract radical expressions and multiply and divide binomial radical expressions. None of these things on their own is necessarily all that hard. Some of the problems are a little bit time consuming. Adding and subtracting radical expressions is something that you would have seen the basics of, at least in geometry. I know that for a fact because I've taught it in geometry this year. Okay, it's part of the curriculum. So even if it doesn't look familiar, you should have seen this before. Not all of it, just some of it. All right, so let's jump into the notes. Like radicals are radical expressions that have the same index and the same radicand, which means the same number underneath the radical. In order to add or subtract, you must have like radicals. Kind of like with terms, you have to have like terms in order to add or subtract them. The same thing applies with radicals. So the same index, meaning the same type of root. They both have to be square roots. They both have to be cube roots. But you also have to have the same exact number underneath the radical. All right, so let's work on simplifying some of these if we can. In order to add or subtract, you have to have the same index, the same radicand. All right, on number 1, do we have the same index on our radicals? Yes, they're both cube roots. Same index. Do we have the same thing underneath the radical? Yes, they both have an x underneath. Those are the two criteria for being able to add or subtract them. When we add or subtract them, we just add or subtract the numbers out in front. So 5 minus 3 is 2. We keep the same index and the same radicand. So 2 cube root of x. It's very similar to combining like terms. On number 2, do we have the same index?
No.
Yeah, they're both square roots. We have the same index. Do we have the same radicands? No. If you do not have the same radicands, you cannot add or subtract them. So in this case, there is nothing we can do. The original problem is our final answer. Okay, if they do not have the same radicands, and you can't simplify anything there, then they cannot be combined. On number 3, do we have the same index? Yes. They're both square roots, so they're the same index. Do we have the same radicands? Yes. What is the radicand? 7. So we can take 2 plus 3 and get 5, but we also need to have root 7. The index and the radicand do not change when we combine them. So there is our answer. On number 4, do we have the same index? No. One of them is a 4th root. The other one is a cube root. If they don't have the same index, we do not even have to keep asking ourselves questions. Those cannot be combined, so we leave it alone. Do we think we can combine on number 5?
Yes.
Yes. What is the index on both? Square root or 2. Okay, we've got the same kind of root. And the radicand on both
X1
is xy. So what would this become?
9.
Good. 9 square root xy is correct. Sometimes you may need to simplify the radicals before adding or subtracting. So we'll focus on number 6 for now. So we're going to go through this problem, and one radical at a time, we are going to simplify it. So if we break down 18, what does it break into? 9 and 2. 9 breaks into 3 and 3. So what can come outside? A 3 from that pair. What stays inside? A 2. So we said a 3 is coming outside, but what is already outside? Okay, the 6 is already out there. What happens with the 6 and the 3? Okay, 6 times 3? Okay, so there was already a 6. We multiply it by the 3. The 2 was alone. It stays in. So we're done with that term. Put our plus sign and move on. What does 8 break into? 4 breaks into 2 and 2. What can come out? What stays in? Okay, a 2 stays in. A 2 comes out. What was already outside? Okay, 4 times 2 is 8 with a 2 left inside. So I'll just write that that's how we're getting those new numbers. Okay, we're done with that term. We bring down that minus sign from up above, and we move on to the last part. We break down 72. You can use 9 and 8. Personally, I prefer 2 and 36. What does 36 break into? Okay, this is why I prefer 36. If you use 9 and 8, that's fine. You would just have a pair of 2s and a pair of 3s. I'm just going to have a pair of 6s.
You wouldn't break that down?
No, if you already have a pair, you don't have to keep breaking down. So what comes out? What stays in? Okay, 3 times 6 is 18, root 2. Do we have questions about how we got this line down at the bottom here? Simplified each one of those one at a time, kept the same addition and subtraction signs. Do we think we're done with this? No, what can we do now? Add and subtract. Now they're all square roots of 2, so we can combine them. Luckily, this problem combines pretty easily. Why?
Well, could we just do the 18? Yeah, do that and cancel each other out.
They cancel each other out. Positive 18 root 2 and negative 18 root 2 are going to cancel out. So what are we left with? 8 root 2. Now, if you were to take 18 plus 8 and then subtract 18, that's fine. You should get the same answer. All right, we have to break down 50. What are we going to break it into?
5 and 10.
Okay, 5 and 10. 10 breaks into
5 and 2.
5 and 2. What do we have a pair of?
5.
What's alone?
2.
Okay, so this becomes 5 root 2. I'm going to write it above this time since I'm running out of room below. Next, put our plus sign and move on to the square root of 32. We could use 8 and 4. Personally, I like 2 and 16 because 16 breaks into 4 and 4 breaks into a pair. I always like pairs. So I have a pair of 4s and a lonely 2. So what does this become? 4 root 2. Minus. Finally, we move on to the 5 root 18. Oops, sorry. There we go. That's got to be 12. Why does that have to be 12? We got to multiply. So we multiplied to come up with that one. We didn't have to multiply on the first one because there was nothing out there. Now we're ready to move on to the 18. 18 breaks into 3 and 6. 6 breaks into 3 and 2. A pair of And a lonely,
2.
okay, 5 times 3,
Negative 15 root 2.
15 with the root 2. Now, it just so happened on both of these examples that we ended up with all square root 2s. It is not always going to happen that way. Okay, but the point of this exercise is that we have to simplify our roots first and then decide if we can combine any of them or all of them. Can we combine any or all of these?
Yes, you can combine all.
All of them. So we have 5 plus 12
17
minus 15.
2 square root 2.
Good. 2 root 2.
They're almost 2.
Next up, we are multiplying binomial radical expressions. So the notes on the slideshow say to multiply, you must FOIL and then simplify. In this class, we didn't really call it FOIL. We called it double distribute. So if you would like to write that instead, that's what we always did in this class. On the end here, this says simplify. I am going to just focus on number 8 for right now, and then we'll bring up number 9. On number 8, for the double distribute, I'm going to write out every single step. I do not expect that you will write it out in quite this much detail when you do it. I just want you to see how we're coming up with this the first couple times while you get comfortable with it. This I do not think you would have seen in geometry, so this I do think is new. So we're double distributing. That means we're going to take the 3 and multiply it to the 2, the 3 and multiply it to the 4 root 5. So again, I'm not expecting that you're going to write this out quite like I am. But 3 times 2 plus 3 times 4 root 5 is the first part of it. Then we're going to take the 2 root 5 and double distribute that. So plus 2 root 5 times 2 plus 2 root 5 times 4 root 5. All right, so let's actually start multiplying these things. 3 times 2 is 6. 3 times 4 root 5 is 12 root 5. 2 root 5 times 2 is 4 root 5. 2 root 5 times 4 root 5.
8 root 5.
8 root 25. Good. But we know, well, we'll get there in a minute. So let's keep on simplifying. What can be combined?
12 root 5 and 4 root 5.
Good. We've got the same index, same radicand. So this becomes 6 plus 16 root 5 plus 8 times, what is the square root of 25? What is 8 times 5? 40. So now we've got 6 plus 16 root 5 plus 40. Well, good. The 6 and the 40 can get combined to be 46. So our final answer, good, would be 46 plus 16 root 5. Now, like I said, I'm not going to expect that every single time you're going to write out every single line of this. I would hope that most of you could get straight to the second line when you're double distributing. And that maybe you'll recognize the root 5 times root 5 as being just a 5 sooner, whatever. Well, however much you need to show is fine. I'm just letting you know I'm not necessarily expecting to count 4 lines of work every time you do it. All right, when we are squaring something, like on number 9, that means we're taking it multiplied by itself twice. So I'm going to create some space up here to write this out expanded. And then we'll work through it. So if I am expanding the square root of 2 minus the square root of 3 squared, that means I'm taking the square root of 2 minus the square root of 3 times the square root of 2 minus the square root of 3. So I'm bringing it up to the top of the page so that I can show my work a little bit better. Are we all okay with how I expanded this? All right. Then we need to double distribute. So that means we are going to take the square root of 2 times the square root of 2. Okay, yeah, let's go ahead and just jump straight to it. So square root of 2 times square root of 2 is the square root of 4. Then the square root of 2 times the negative square root of 3. Negative square root of 6. Are we all okay with that? All right, then again, we have to take the negative square root of 3 and double distribute that to the back. So again, negative times a positive is a negative square root of 6. And in the very back, we have a negative times a negative. That would be a positive square root of 9. I would not recommend dropping any of your square root signs on the first step. If you want to go ahead and multiply on the first step, that's fine. Now let's go through and start simplifying. What is the square root of 4? 2. In the middle, these are both square roots of 6, so they can be combined. And negative 1 minus 1 is negative 2 square roots of 6 plus square root of 9 is 3. Now what can get combined?
2 and 3.
Okay, the positive 2 plus 3 would be 5 minus 2 root 6. Now, I have had students in the past that have then told me that the answer is 3 root 6. Why is that incorrect?
Because the negative 2 square root of 6 by itself.
Okay, well this 5 does not have a square root of 6. Okay, so these cannot be combined, so that would be incorrect. Our final answer should be the 5 minus 2 root 6. Okay, I also, just an alternative situation in case you were tempted to do this. In the past, I've had students say, oh, 2 minus 2 is 0 plus 3, so 0 plus 3 is 3. Don't be that person either. Don't break up a number that's with a radical. Those are stuck together. Don't do this. A big N-O. No. All right, let's start going through number 10. When we double distribute, 2 times 2 is 4. 2 times negative root 3 is negative 2 root 3. Root 3 times 2 is a positive 2 root 3. And root 3 times negative root 3 is negative root 9. What here is going to cancel out?
2 root 3.
Okay, the plus and minus 2 root 3s. Okay, those go away. We got a negative and a positive of the same thing. 4 is just going to stay 4. Minus 3. The square root of 9 is 3. 4 minus 3 is 1. So that is our answer, just the number 1. Questions about 10? All right, on 11, we start with our double distribute. We have the square root of 5 times the square root of 5. The square root of 25. The square root of 5 times the negative square root of 2. Negative root 10. Square root of 2 times the square root of 5 is a positive root 10. The square root of 2 times the negative square root of 2.
Negative 4.
Negative
Root 4.
root 4. Questions about that first step of multiplying? Okay. Then what cancels?
10.
Okay, this will not always happen, but on these particular problems, the plus and minus root 10s cancel each other out. The square root of 25 is 5. What symbol goes next? Good, a minus sign from back here.
Minus 2.
Minus the square root of 4 is 2. 5 minus 2 is 3. Notice in numbers 10 and 11, the binomial product was a real number. These are called conjugates. They differ only in the sign. We talked about conjugates a little bit back in chapter 6, you might recall. To divide binomial radical expressions, you must multiply both the numerator and the denominator by the conjugate of the denominator. After rationalizing, you must simplify. So when we multiply a binomial by its conjugate, we'll end up with a real number, meaning the radicals went away. All right, our first couple examples of this. I'm actually going to take away 13 while I do number 12, just so I have lots of space. All right, the directions said, in order to do this, we multiply the numerator and the denominator by the conjugate of the denominator. So what is the conjugate of the denominator? Good, 1 plus root 5. So that's what we multiply by on the top and the bottom. Personally, I like to put all of these things in parentheses. It helps me remember what I'm doing. The conjugate means we change the sign. Keep it all the same, but change the sign. Okay, so that's step 1. Figure out what the conjugate is, multiply it to the top and the bottom. This is when it gets a little tedious because all that stuff we were just doing on the last 4 examples, we now have to do it twice in one problem. We got to double distribute in the top, and we have to double distribute in the bottom. Now, what I prefer to do is to write my work for my double distributing down here and not write anything on my fraction bar until I'm done simplifying it. Does that make sense? So what I prefer to do is over here I'm going to do 3 plus root 5 times 1 plus root 5. And I'm going to work it all the way out and get an answer. And then over here I'm going to do 1 minus root 5 times 1 plus root 5, work it all out, and then put my answer up here. You do not have to do it that way, but to me it gets a little confusing otherwise. Okay. All right, so let's start with the numerator product. 3 times 1 is 3. 3 times root 5 is a positive 3 root 5. Root 5 times 1 is a positive root 5. Root 5 times root 5 is the square root of 25. Okay. So we start combining 3 plus, what can be combined in the middle here?
3 root 5.
With the
3.
with the root 5. These are both root 5s. What number is in front of this root 5? A 1. 3 plus 1 is 4 root 5. The square root of 25 is 5. What can get combined now? 3 plus 5 is 8. Plus 4 root 5. So this is what I'm going to carry up to my my numerator. 8 plus 4 root 5. Now we're going to repeat the process to get our denominator. 1 times 1. 1 times root 5. Negative root 5 times 1. Negative root 5 times root 5. Negative root 25. What cancels out? Okay, the negative and positive root 5s cancel. We're left with 1 minus, what's the square root of 25? 5. 1 minus 5 is? Negative 4. If you do not end up with just a single number in your denominator, something went wrong. If you still have a radical in your denominator, something went wrong. Then we have to decide if we can simplify this. What do we think?
Yeah, 8, 4.
Okay, this goes back a little bit to when we would simplify with the quadratic formula. The 8, the number in front of the radical, and the number in the denominator all have to be divisible by something. They're all divisible by 4. Okay, let's use it as a negative 4 instead, so that way our denominator totally goes away. So this would be negative 2 minus 1 root 5. Okay, and we could put it over 1 if we wanted to, but the point in treating it as a negative 4 was to get rid of the denominator. So we have negative 2 minus 1 root 5. All right, on 13, we need to multiply the numerator and the denominator by the conjugate of the denominator. What is it?
Negative root 3 plus root 7.
Close. Good. Only the sign in the middle changes. Root 3 plus root 7. If we change both signs, that would be the opposite, which is similar to but not the same as the conjugate. So then root 3 plus root 7. Same thing, top and bottom, just like when we were rationalizing denominators on yesterday's quiz. I like to have my parentheses there so that I remember to double distribute. Okay, so over here, I'm going to show my work. We have 5 minus root 21 times root 3 plus root 7. So let's do that one first, and then we'll worry about the denominator. 5 times root 3. It's 5 root 3. 5 times root 7. It's 5 root 7. Negative root 21 times root 3. Negative root what? 63. Good. Negative root 21 times root 7.
47.
Good. Negative root 147. Make sure you're watching your signs when you do this. All right. At the moment, can anything be combined?
Yeah.
At the moment? Right here? No. Why not? Nothing's the same. We've got a root 3, root 7, root 63, root 147. None of those match. However, we might be able to simplify a couple of these radicals. We should hopefully recognize that root 3 and root 7 will not simplify. However, root 63 will. if you need to. You can break down 63 into 9 and 7. 9 breaks into 3 and 3. So what does it become? 3 root 7. Very good. Notice that I kept the minus sign. Again, keep the minus sign back here. 147. If you're not sure about it, in order to get 147, we had to multiply 21 times 7. So we can break it back into that. 21 breaks into 3 and 7. So what does it become? Wonderful. Questions about how we simplified those? Now that we simplified them, what will combine?
5 and 7, 3 and 7.
Okay, so the root 3's can combine together. 5 root 3 minus 7 root 3. 5 minus 7? So negative 2 root 7. And then in the middle we have 5 root 7 minus 3 root 7. Sorry, 5, that's a 2 root 3. 5 root 7 minus 3 root 7. 5. Okay, positive 2 root 7. Can we combine those? No, why not? They don't have the same radical. So we have to leave those alone. So that is now what's in my numerator. Negative 2 root 3 plus 2 root 7. I still need to know what's going to go in my denominator. We have questions before we work out the denominator. Nothing? Okay, then let's double distribute the denominator. Root 3 times root 3. Root 9. Root 3 times root 7. Root 21. Negative root 7 times root 3. Negative root 21. And negative root 7 times root 7. Negative root 49. Okay, the square root of 9 is 3. What happens to the root 21s? They cancel. Minus the square root of 49 is a 7. 3 minus 7 is negative 4. That is what is in my denominator. Then we have to decide if it can simplify. Yes, all of these numbers can be simplified by a 2. So yeah, you can use a 2 or a negative 2. The denominator will not go away completely. I like using a negative 2. I feel like it cleans it up a little bit. Negative 2 divided by negative 2. So positive 1. 2 divided by negative 2. So negative 1 root 7 and negative 4 divided by negative 2. Oop. A negative divided by negative is a positive 2.